Hey everybody! Today we're going to take some notes on forces in motion. It's not going to be a very long notebook session, but we do have a worksheet to do afterwards, and I want to send you over to Quizlet. So I'm going to embed that into this video so that you can do that and do your uh, vocabulary practice today or tomorrow, whichever you get to. So even if you are not done with your vocabulary and your forces in motion lab, then I still want you to watch this first, which I'm probably going to go over with you at the beginning of class. And then the worksheet that I'm going to have you do, you can wait to do that until tomorrow if you're not done with vocabulary especially. So do things in order still, but I do want you to watch this video today. So the first thing we're going to do is start a new notebook page, title it Forces in Motion. Make sure you're adding it to the table of contents. I did do a notebook page here, so you can kind of follow along with what I did today. Forces in Motion, we're on page 19. Today is the 1st of December. So the first thing we're going to write down is just what is a force, and we know from our vocabulary that it's a push or a pull. So go ahead and just write down force is a push or a pull. I did put on the side here the sum of forces in my little bubble or cloud, it looks like. Sum of forces equals the net force. So if you wanted to put that off to the side too, and then draw a little arrow here, I kind of colored mine in because we're going to talk about balanced and unbalanced forces now. Again, this is just review from your vocabulary, but I wanted you to have it in your notebook. So I want you to do two columns after your arrow here, and then kind of add little arrows to both sides, balanced on one side and unbalanced on the other. In a balanced force, the net force or the sum of forces equals 0, and there's no movement. In an unbalanced force, net force does not equal 0, it's anything but 0, and there's movement. The types of force, so you can go down below. Types of force, I highlighted 3 here, and then I put some more below. But the 3 that's highlighted, I'm going to obviously have you write stuff down underneath. So friction is our first one. See how I have it here? Friction resists slide. So if anything is sliding, friction is always acting against it. A car on sandpaper, a toy car on sandpaper. You walking across the floor. Anything that, like, if you slide at all, there's friction working against it. It slows movement down. Buoyancy, on the other side, this is the upward force in fluid. And if you remember from our matter unit, fluid can be air or water or liquid. So gas, liquid are both fluids. Anything that's like an upward force is buoyancy. These two, friction and buoyancy, work against gravity. So I kind of put gravity in the center. I put little arrows on my notebook page to kind of show that it's working against them. Actually, I didn't do that right now. So you can see the little arrows that I put in between to just show that they're like fighting it. Buoyancy is fighting gravity, friction is fighting gravity. Gravity is in everything. So we have gravity. There's a force of attraction in between atoms. There's a force of attraction in between anything that has mass. And the more mass something has, the more gravity it has, which is why the sun pulls the planets pull moons, and all of the life on it. So all of the life on this planet. So gravity depends on size. More mass equals more gravity. So before we go on to the next one, I just want you to write down others on the bottom. We're going to talk more about this in our next unit. Other types of force are magnetic, electric, and air resistance. Air resistance is why cars are made like aerodynamic, so that the air resistance is kind of like friction. It slows movement. So if you have an aerodynamic car, the air just flows right over it instead of pushing up against the object. So air resistance is a real problem if you want to keep moving, because like we talked about earlier, any kind of force either pushes and makes something move or pulls something back and restricts movement. So air resistance is another one of those forces. In the next unit, we'll talk about magnetism and electricity a little bit more. The next slide, motion. Motion is our change in position over time. So just on the bottom, I wrote 2 more vocabulary words. The motion and speed, this is what our worksheet's going to be on. We're going to be graphing motion and speed over time. So change in position over time is motion, and then the next one is speed, is distance over time. So you can write distance over time out and then make sure you're writing d over t. I showed you a little graph here, and this is the worksheet you guys are going to work on now, or when you're ready. I'll go over this first part with you, okay? So when you're done, let me make this bigger. Okay, so on number 1, it says, what's the title of the graph? Now, if you look up on the top here, graph 1, this is where it tells you the title. So it's D versus T. D means distance. T is time for a bowling ball, okay? So that's what you would write in number 1. Number 2, where's our y-axis again? Here's our y-axis. Distance, that's the units, meters. The units for the x-axis, our x-axis is time, and our unit is seconds. If you were to divide the units, what would you get? You'd have distance over time. You'd have meters per second. So m over s. What did we talked about this? What's another word for slope? It's like an incline. But what does the slope of a distance versus time graph tell us? If we're talking about distance versus time, it talks about this incline here, and we're seeing this incline, right? We're seeing how far something travels and how fast. So it's telling us speed. Okay, the slope tells us speed. Does the slope of this diagonal line change? No, it doesn't. In this graph, it doesn't change. It's just a straight shot, okay? So what does this tell you about the motion of the bowling ball? The motion of the bowling ball, the distance over time, never changes. So the motion stays the same throughout. Now, if you look down at other graphs and the ones on the back, there is a change in the slope. So I want you to try and determine what happens if you're going, think about it, distance over time, if there's a smaller slope and then a more inclined slope, what do you think that means? And if you need help with that, let me know. But I want you to try to figure it out on your own. So, the things you should be doing now, this worksheet, if you're done with the Forces in Motion Lab and your vocabulary is number 1, it's due today. And then going to Quizlet, hopefully you have that link open now. I want you to sign up for my class, and I want you to play some games. I'm going to be able to see everybody that's been able to play games. So between today and tomorrow, vocabulary, Forces in Motion Lab, the distance graphing sheet, and Quizlet. Okay, so good luck. Let me know if you need any help.